Hello everyone, it's 3 o'clock, so let's get started. Big hello from me. My name's Jon Cheek. I'm the founder and director of UniTasterDays. It's great to see so many people here, even though it's half term, for this engineering subject special, so thank you very much for joining us. This session, this is live, but the session's also going to be recorded, so if you've got any friends or family members that couldn't tune in now, we will, fingers crossed, be adding the video to the website unitasterdays.com/Tuesdays. Fingers crossed from tomorrow, so you can browse that at your leisure as well. This is our 5th week now of running UniTaster Tuesday events. Over 1,000 students so far have joined them, and I hope you find them really useful. We run general university events at 12 o'clock where students find out about general aspects of universities. That might be student finance, it might be how to apply to university, etc. And then we also run subject events at 3 o'clock, which is what this is, looking at engineering, where students can find out more information about a particular subject area. And I know that these events are going to be very popular, and it's great to see, even though it's half term, there's lots of people that are attending, so fantastic. In terms of this session, if I could just quickly introduce the panel, because you will want to hear from them, it's not about me. That is, our first speaker is going to be Patricia Ashman, who's joined us from Coventry University. I'll give Patricia a full introduction before her session, so I won't go over job titles and things now, but Patricia's going to talk to you about, essentially about careers in engineering. And our second speaker is Dr. Elaine Brown, who's joined us from Bradford University. And Elaine is going to do a session which is going to look at skills and competencies that universities look for in engineering students, and also help you when it comes to selecting an engineering degree. So big welcome to Elaine as well. Just a couple more things from me, and then we'll pass the floor straight away to Patricia. There's a Q&A open throughout, so at the bottom of the screen you'll see a Q&A tab. If you've got any questions at all, please use the Q&A tab, and it's absolutely fine to post questions anonymously if you don't want to provide your name. In fact, I'd encourage you to post them anonymously. That's absolutely fine. No issues there at all. We'll finish today. If you have any plans later on and you want to make sure that you fit with that, I'll make sure we finish certainly by 4 p.m. And likely it is a fair bit before that. And after the event, the final bit from me to let you know about is after this event, if you really get a feel for university events and you want to find out more about university events, we run these events on Tuesdays, but also universities themselves, of which Coventry and Bradford, which is where our speakers are from today, run some fantastic events as well. So if you would like to find out more about particular university events, really good useful website for you is unitasterdays.com/online. And that's essentially a directory of university events, and there's approaching just online events, about 500 events on there at present, so that should be really useful for you. Right, if I can now introduce the first speaker, please, and that's Patricia Ashman. Patricia is going to speak to us about careers in engineering. She's the, hopefully I'll get this right, Patricia, Associate Head of School at Coventry University, and also an Associate Professor, I've lost my list, of, is it Mechanical Analysis, Patricia? I hope I've got that right.
Yes, correct. Thank you. Thank you, John.
Thank you. Patricia, I'll pass the floor to you, a session on careers in engineering. Over to you. Thank you.
Thank you. I'm just going to share my screen with everybody first. If you give me a moment. So hopefully that's coming on. If John can just give me a nod when that's on. I'm not sure.
Thanks, Patricia. We've got the presentation up. So if you just click slideshow on the PowerPoint, and then
should work. Okay, great. Thank you so much. I'm really thrilled to be here with UniTasterDays and with Dr. Elaine Brown to talk about my favourite thing, which is engineering. The beautiful, creative, innovative world, mathematical world, problem-solving world that is engineering, with all its rainbow colours of engineering disciplines and industries. So hopefully this presentation will start okay. Yeah, that's great. I'm on split screen, so it's a little bit appearing all over the place. So yes, I'm from Coventry University, the School of Mechanical, Aerospace and Automotive Engineering. John has introduced me. I'm also responsible for admissions to our engineering programs. This is our beautiful building, and we're very proud that we're currently ranked number 3 in the Guardian University League Table for Mechanical Engineering. And these are the courses I'm specifically covering, the kind of industries and jobs that you can go into. These are all mechanical disciplines, so automotive, motorsport, manufacturing, etc. They are all part of the mechanical engineering universe, and I will come back to that during my talk. The question I want to ask you right now is, I'm going to pause and give you a moment to think, is what is engineering to you? What is an engineer? So just giving you a few seconds. If you're thinking spanners and dirt, oil, fixing cars, washing machines, then give yourself 1 out of 10. There's so much more to engineering than that. It's the application of science, mathematics and technology to solve real world problems. It's a creative outlet. If you're a problem solver, if you're a person who thinks, you know, why has somebody done it this way? And why has anybody thought of solving this problem this way? Then you're already thinking like an engineer. And that is the world that is so important in transforming societies and economies, not just in the UK, but globally. And I'm going to talk to you about some of those opportunities during the course of the next 10 minutes or so. So what do engineers do? What don't we do? We create prosthetic limbs. We think of course we do, we design cars, etc., and planes and rockets. So that's the obvious thing we think about. But we are the engineers that engineer iPhones. We are the engineers that are going to work out how we deliver the vaccine for the coronavirus when that's finally invented. You know, what is the delivery system? We are the people that are working out the track and trace apps that everybody is talking about, how to get better water supplies, how to design beautiful makeup boxes that are magnetic and you can take things in and out of. So what don't we do? We are creators, we are innovators, and we transform economies and societies at all levels. We do this all over the world in almost every industry. I can't actually think of an industry that doesn't need engineers, relies on us engineers to thrive and grow and transform and develop. And that's why there is a huge global demand for engineers, and nicely why we're paid so well. And I'll talk to you a little bit about salaries in the course of this talk. So engineers are problem solvers, and we do find solutions to some of the world's biggest challenges. Things like this. Now, I'm an older engineer, and I look back at some of the things as older engineers have brought to this world that we thought were transformative and we thought were marvellous, like cars, for example. But alongside that, we brought in a lot of other problems. So when we solve the problem of transport, when we solve the problem of illness, infant mortality, what we're doing is we're creating new problems, and you young engineers are going to be the ones that are going to create the new solutions, but also solve some old problems such as sustainability issues, the environment, etc. But you're going to look at some exciting stuff. How are we going to put people on Mars? What do we do to keep our world secure and safe? And that is going to be your challenge as the next generation of engineers, solving some of the problems that we older ones have done, but just not just using your technical expertise, but also just being aware of the world around you. And some of the best ideas come when we don't think of it. There's the old story that Newton discovered or realised gravity existed when an apple fell under his head when he sat under a tree. So it's not just about applying the science, it's also about the inspiration and innovation. And if all of those things describe you, then you're well on the way to becoming a professional engineer in the world. We are the inventors who turn ideas into reality. So this is a good opportunity when we're thinking about problem solving and when we're thinking about this idea of creativity. It's a great opportunity, a time to talk about equality, diversity and inclusivity. It's huge in engineering at the moment. When we want creative new problem solving, what we want to do is encourage different thinking, and that's where the diversity agenda comes in. Not only is there a massive skill shortage of engineers, what we want to do is bring people who have a different way of looking at the world, either through disabilities, through different socioeconomic status, their gender, their age, their race, all of these things are really valuable to the engineering world. And so it's a fantastic time to come into engineering. There's so many initiatives that will encourage you either at an employer level, and also at a university level to encourage this diversity in the professional engineering industry. So is engineering a good career choice, and what can we do with that? Well, there's so much data. I would point you to the Engineering Council, which is the governing body for engineering in the UK, and it is in crisis. Engineering is in crisis. There's a huge skills shortage, and I'll talk to you some of that data. But what I thought I might do is just tell you a bit about myself and my career. So this is me when I was somewhere between 18 and 19 in my first year of university, doing mechanical engineering. So your kind of age. I loved maths and physics, and I really didn't know what engineering was. And I found myself on an engineering degree because I didn't want to be a teacher, although ironically now I am an academic. And I managed to get a sponsorship with Jaguar Cars, which set me off on a really brilliant industrial path. And I've worked all over the world with different industries. And these are just some photos from, I don't know if these are showing, the last few years. So this is me in America with some of my students. So one of my research areas is in autonomous vehicles at the moment. When I started off as that young 18-year-old, I'd never thought that the world would be looking at driverless vehicles and that I would be part of that research world. And so this is us at University of Michigan at their autonomous vehicle testing site. This is me last year with some of my students at Lotus, working on some of the next generation Lotus car projects. December in Bangladesh, working on some fantastic projects there. And last year was presenting one of our innovative projects with Keir Starmer. You've probably heard of him now, and Robert Peston. And this is just, I'm not showing off. What I want you to know is that that being an engineer has just meant that I've travelled the world, been involved in so many exciting things, met my husband, had a family, doing all the normal things as well. And I'm by no means special. There are people much more exceptional than me in the engineering world who've done some incredible things. And so from that 18-year-old who really didn't know what engineering was, who just liked maths and physics and problem solving, you know, it was a happy accident for me to get into engineering, and I've loved every minute of it. And now it's a privilege to inspire and work with the next generation of engineers. So in terms of salaries, this data is from last year. My graduates are often starting on salaries of 35,000. It's some of the highest paid graduate salaries, comparable to medicine, law and computer science. And for chartered engineering, you could be looking at currently around £68,000–70,000 as a medium. And of course, it's sky's the limit. There's a lot of variance on there. And the graduate employment statistics are fantastic. And if I'm assuming the fact that you're on UniTasterDays means that you're all researching and wanting to know all the best things to do, the best universities, the best courses, the best careers. And if you haven't looked on the government site, DHLE, the Delhi site, and it tells you about all the data around graduate employment. And for my particular students, we're looking at around 100% graduate employment within 6 months. And again, that's all on the government site. So you can compare universities and courses, etc. The value of engineering in the UK is huge, and it's growing. So the GDP, the gross domestic product, it contributes billions and billions of pounds. It is an important industry and one that is supported heavily by the government. And because of the huge skill shortage, just scooching on a little bit to here, because of the huge skill shortage, the government actually announced last year as the Year of Engineering, and some of you may have been involved in some of the many activities, because the government is worried if we don't get engineers into the sector, society will not continue to evolve and transform. And this data down here is super important, because you want to know that when you do your engineering degree, what are the opportunities for you. And I understand that the COVID situation has thrown some spanners in the work, and I'm sure myself and Elaine are happy to answer any questions on that at the end. But right now, this data says that there are just not enough young engineers coming through to fill engineering vacancies. And that's not just in the UK, it's globally. And as young engineers, you have a whole global world opening up to you. And right now, opportunities in places like China and India are just phenomenal and really something to think about. So why would you be an engineer? There's lots of great reasons. I've mentioned some of them. You have more, looking right down in the bottom corner here, arguably engineering has more impact on the world than any other profession. You get to use your creativity, you get to travel, you are a senior professional person in the world who is very highly valued, and there's opportunities for lots of promotion and good salaries and opportunities. And up here, you get to solve global problems. So it's an incredible profession to be in. And the data shows that the opportunities are there and the employability is fantastic. And you can just Google, there's lots of articles that talk about shortage of engineering skills. This is an article by Rolls-Royce. All the big companies are really doing a big push to encourage you young engineers to come and join them in their graduate roles. And where can you work in engineering? Where can't you work in engineering? I've listed a few things there with some pretty pictures. So obviously the big obvious ones are aerospace and defence, automotive, which is where my majority of my background is. My background is also in the railway industry, but construction and building, manufacturing, that is the big skills shortage. And I do encourage you to look at manufacturing. It's 100% employability. It's the highest starting salary of any engineering discipline. Most of my mechanical engineers will end up becoming manufacturing engineers. Medical profession, of course, power and energy, etc. But the more things you might not think about. Some of my students are headhunted off to become investment bankers, or they then do a further degree in law. The beauty industry, the fashion industry, humanitarian. I personally have done some volunteering work around the world doing some humanitarian engineering projects, and often as part of your either your university degree or also your career, there are opportunities for doing humanitarian work. It's a big aspect of most companies is corporate social responsibility. So I'm coming to the end of my talk, really. The salaries are fantastic. The opportunity to use a broad, diverse range of skill sets is huge. The outlook for employability is great. The range of courses, I mentioned some at the beginning, like aerospace and mechanical motorsport, but there's things like electrical, there's computing, there's civil engineering, there's disaster management engineering. There is a whole world of engineering there that fits you. And there is not one that is better than another in terms of employability or opportunity. There is one that fits you better than the rest. And your challenge is to think about what is it that you love? Where do you want to see your career? And finding the discipline that, whether it's motorsport or civil or electrical, find the discipline that's going to keep you happy. So that's the end of my talk. Thank you for listening. I believe I'm going to take questions at the end, but I'll hand over to Jon now. Thank you.
Thank you, Patricia. That was brilliant. I have learned so much from that about engineering. I wish that, to be honest, I had a session like that when I was perhaps a little bit younger as well. So Patricia, thank you very much. Patricia, do you mind just closing? It should say stop share on your screen. It'll just come back to me. But thank you again, Patricia. And with your permission, Patricia, afterwards, if you're happy for those slides to be shared, I'll pop them on the UniTasterDays.com/Tuesdays webpage. It's just cutting off a little corner of it, so it just means that students after the session can have a look at the full slides alongside the presentation again. Thank you very much. Brilliant. Patricia, loads of questions that have come in the Q&A, so if you don't mind answering a few, that would be brilliant as well. Thank you so much. And if I can just now introduce our second speaker, that's Dr. Elaine Brown, who is joining us from the University of Bradford. Elaine's going to talk about skills and competencies in engineering and also in terms of actually picking courses in engineering, give some tips along that way. So Elaine, without further ado, thank you for all the work on the Q&A. So students, there's the many questions that Elaine has answered on the Q&A you can take a look at, but Elaine, I'll pass the floor to you. Thank you very much.
Thank you. Hello, everybody. I'll just have a go at sharing my presentation. So good afternoon, everybody. It's interesting listening to Patricia. Patricia and I haven't met. but many of the things that she was talking about are absolutely identical to the things that I think are really important for engineers and for young people like yourselves who are thinking of studying engineering. So there are some things, because I was answering the Q&As, I wasn't always listening to all the details, so there may possibly be some things that I repeat, but that's actually quite a good thing, because that means that we've got the similar message. So yes, as John was saying, my name is Elaine Brown, and rather similar to Patricia, I'm also a mechanical engineer. So I'm a chartered mechanical engineer, and I know a few people have been asking about chartered status within the Q&A, so I'll talk a bit more about that later. Now, even though I'm a mechanical engineer, I also think it's important to know that I actually work in a department of chemical and process engineering. So straight away, you can take from that the interdisciplinary nature of engineering. So hopefully that will put your mind at rest a little bit, because one of the things I find that people are wanting to ask is, what engineering discipline should I study? And actually there is a lot of mobility within engineering. So in general, often it's the skills and the competencies that you as an engineer will develop that an employer is looking for, and the actual subject matter you can move around within your engineering career. So you've joined this afternoon, you're thinking of studying engineering, it's something that you're thinking about. What do you need to know at this stage, both in making yourselves marketable to a university? So how can you know what kind of things a university is looking for? But I think more importantly is, how can you decide whether that university is going to help you? And it's about you, it's about yourself. So this is really important. So I've come up with a few things that I think are important. But it's interesting that what Patricia was saying about her interest, she didn't know what an engineer was when she was your age, and that was very similar to me. The reason I got into engineering is because I basically discounted all of the other things that I could possibly do. I liked maths and science, and I liked English, and they were my favourite subjects. And really, it was a process of elimination for me. I thought of lots of other things, and they weren't careers that I was interested in. And then I was lucky enough to go on a course run by something called WISE, which is Women in Science and Engineering. They were running a one-week course at Manchester. I didn't go on it because I wanted to be an engineer. I went on it because it was a week away in Manchester, and I thought that would be fun. But literally within the first morning that I got there, I realised this is something that I could really enjoy. So the reason I say that is because I think as well, sometimes in the media we're told, this was my dream, this is what I always wanted to be, and I'm so, this is so special to me. But for some of us, actually, we find these things just by looking through stuff. So don't worry if you don't have these big light bulb moments. Hopefully you will find something within the presentations today and within all the stuff you read about engineering that makes you realise it could be something for you. So I thought it'd be useful to think about what engineer actually means. The word engineer comes from the Latin ingenieur. I never did Latin, so please excuse if I have a strange pronunciation, which means to contrive or devise. It's also, the root of the word also means clever. So it comes from cleverness. And what do we mean by clever? Well, really, what an engineer is doing is turning ideas into real solutions. So where a scientist might think about scientific facts and think about how we can apply those facts, an engineer tends to come at things more from the problem. So as Patricia mentioned, we have this issue at the moment, the COVID-19 issue. We have a vaccine being developed by the scientists. They're using the science to develop that vaccine. In order to get that out to people, we also need the engineers so that it can be scaled up and it can be produced, and that we can all get it, so not just a few people can get it. So you need both scientists and engineers in order to make everything work, but we come at things from different perspectives. And it means that the skills are a little bit different compared with what's good for one type of career might be a little bit different from what's required from an engineering career. An engineer can't just come up with something that's an amazing solution. It also has to be practical. So at the heart, many of the employers engineers work for are companies who are looking to make profit. So engineers have to come up with something that is cost effective as well as being a very good technical solution. So to put in context where I'm coming from, at Bradford, we have 4 departments of engineering. So we've got mechanical, civil and structural, chemical and process, biomedical and clinical. And as I told you before, I'm a mechanical engineer, but I work in chemical engineering. So there's a lot of cross-discipline stuff going on. But the reason I put these up is because I know that at your stage, there'll be lots and lots of other courses that you might think about, and you might be able to, you might be trying to navigate through them. So this slide is just a list of loads and loads of different types of engineering courses that you might see advertised. But what I want you to realize is that the root of all of these courses lie within these specific kind of root engineering areas. So what that means is you might look at a course which is really, really difficult to get into, and the university that you're looking at might require very, very high grades, and you might think to yourself, oh, it's because it's a really difficult engineering discipline. But actually, it might just be because there's only 1 or 2 universities offering that, so it's a market demand. So if this is the case for you, one of the things you might want to think about is, well, if I study something a bit more broadly, like mechanical engineering, then can that lead me into other careers or more specific careers? And the answer to that is absolutely yes, it can. So try not to get too worried. At this stage, I would go with the kind of things that interest you most and go along with that degree and applying for those degrees, and you can specialize later. So what makes a good engineer? This is important for you if you're filling in your competencies and you're doing your applications and you're writing your personal statement. So an engineer, we like solving problems. We like to think about how things work. Some engineers like to take things apart. Others just like to think about these things. Some engineers are very practical. Some are more theoretical. Essentially, most engineers have a creative part to their brain. So we enjoy being creative. And that can mean that we're good at ideas, or it can mean that we're good at taking apart ideas. So there's lots of different ways of being creative. We want to work with people usually, or we want to help people ultimately, because most of the things that we are designing and working on are done for the good of humanity. You do have to have good maths and science skills, as I'm sure you'll be aware. That's because when I talked about having a robust solution to a problem, we use maths and we use scientific analysis to basically test everything out to work out what's the best approach to use. So you have to be curious, you have to ask questions, you have to not be worried about things going wrong within limits. You don't want to design something that's not going to be right, but in the testing phase, you have to keep an open mind. So these are things that engineers need to be good at. So that means that an engineering degree has to help you to develop those skills. Ultimately, an engineering degree will give you the technical knowledge. So there will be modules where we teach you different technical information. But really, the crux of an engineering degree and a good engineering degree is that we are allowing students to develop the skills and competencies that the employers need. So these would be the analytical skills, the problem-solving skills. You need to be able to work independently, so you need to be competent, but you do also need to be able to work as part of a team. Your skills in communicating with other people are absolutely vital. This might mean talking to other people. It might mean being able to write a concise report. Often it will mean taking a lot of information and picking out the important parts to share with team members or people in other teams. So these actual skills, this is really what you are practicing and what you are trying when you actually take on an engineering degree. A couple of people were asking about chartered engineer status. So a chartered engineer is registered with the Engineering Council. You have to have a degree up to master's level. So you can look at integrated masters, which are called MEng degrees in some universities, or you can look at a bachelor's degree and then continue to do with an MSc afterwards. But you have to be educated to master's level, and then you have to have work experience. And you have to have work experience within where you're mentored by another engineer so that you're developing these skills. And after a few years, it varies depending on which professional body you're looking at. But essentially, 4 to 6 years after graduation, you might be ready to look at becoming chartered. The advantages to that, chartered engineers do earn more money, but actually, really, for me, the most important advantage is that you tend to get more responsibility and therefore a more exciting career. So if you want to know whether the course you're looking at would allow you to go on that path, what I would recommend is that you look to check if the courses are accredited. So these are the bodies that will accredit the courses. So we've got Institution of Mechanical Engineers, Institution of Chemical Engineers, institution of civil engineers, and there's also an institution of structural engineers. So if you look on their websites, there is loads and loads of information about how to, the different careers, how to get into different fields, all of that kind of stuff. I would definitely recommend that any course that you apply to is actually accredited by one of these bodies, so you can check that with the universities. Once you've chosen your course, so you might think, okay, I know I want to do mechanical engineering, now which university will be best for me? And this list here that I've put together is essentially what I think are some of the questions that you should ask, and I'm just going to go through each one in turn. So you might want to think about what's on the course, how big the course is, how many people are on it, how much practical work, what the kind of the scenario of the teaching is, how much the university will invest in students. This is quite an important question. The industrial links, student satisfaction, absolutely vital. And then research expertise. So I'm just going to very quickly go through what you could think about for each one. So first of all, is one course the same as another? Fundamentally, the modules will be the same no matter which university, which accredited course you choose. So we'll all teach maths, we'll all teach fluid mechanics, we'll all teach thermodynamics. They might be taught in slightly different ways, but essentially the fundamentals are the same everywhere. So what you might want to look for to help you to choose your course is to look for modules and universities that will have an industrial or a research perspective to some of their modules, and also to look for universities that will give you a little bit of choice so that you can personalise your degree. So at Bradford, the kind of choice that we would offer, and we have what we call a multidisciplinary first year. So it's not a common first year, but we have modules that cross the disciplines. The reason we do this is because that means that engineers from different disciplines will get the chance to actually work in multidisciplinary teams right from their first year at university. But ultimately, it also offers students a little bit of choice. So if they're working on a project and they think, actually, maybe I should have applied for a different type of engineering, then they do have a bit of flexibility. And some universities will run things in this way. The other things that we do to offer students some personalisation of their degree is there are optional modules, usually within third and fourth year, so your BEng or MEng year. And I'll say a bit more about this a bit later when I talk about the research aspects of universities. One of the things that we do bring into things at Bradford, and I know quite a few universities are doing this now, is using real examples of problems for our students to solve. So real case studies from industry or from our own research. And that makes it lively and new, and there's lots of exciting things. And this is actually a good point to remember. In engineering, there is hardly ever one solution. There are almost always many, many solutions, and we have to choose the right one. So being able to trial all these things out is a really good part of a curriculum. Class size, cohort and class size. I think this is quite important when you're making your choice. You'll know from looking around at universities, some universities will take hundreds of students on a course and some will take not so many. So for my department, we're a fairly small department. We try to take about 70 students each year. The reason for that is because we have quite a high emphasis on small group work and on practical work. So if we had hundreds of people on our course, then we wouldn't be able to do that. So we've made a conscious decision to do that. And what it means is that I know my students very well. So I know all my students have good contact with all the tutors. That might suit you. Our students certainly appreciate it. But you might also prefer something that's a little bit more anonymous, where you're one of a few hundred students, and maybe you don't want to be quite so close with your tutors in terms of seeing them so often. So it's really important when you go to look at universities, whether it's a virtual open day or you can go and visit, to actually find out about how many students there are likely to be. So within the course at Bradford, for example, because we have a high emphasis on practical work, we actually get our students to develop the skills and competencies of the engineer through doing lots of practical work. So we have lots of hands-on work. So I've just got a few photographs there where you can see the kind of group sizes. So this one's a little bit bigger, but essentially they're all sizes that the tutor is quite close to the student, so we can answer and help with a lot of the problems. And so when you go to look at a university, ask them, how much access will I get to tutors? What kind of group sizes are there? Can I have a go at doing things myself, or is it all done on demonstrations? These are good questions to ask. You might also want to think about how engineering is taught. Yes, we tend to, in engineering courses, we tend to have some lectures, but a lot of the mathematical things that we study, we can deliver some of the information from lectures, but a lot of the competency comes from practice. So we need a lot of tutorial time as well. And a lot of engineering education covers what we'd call the T-shaped professional. So essentially this bit here, your boundary crossing competencies, that means that you will know a little bit about a lot of things. And then your deep part is where you will know a lot about your own discipline. If you only know the deep part, then you don't know where you're going to fit in. So it's really difficult to solve bigger problems. If you only know the shallow part, then you can't actually engage very well with your own contribution. So it's important to have both. Investment and investing in people. So investment means things, but it also means staff and tutors. So when you go to look at universities, have a look both at the lab space, like the kind of thing that you see on the image here, but also ask about who is going to teach you. Is it the lecturers, or is it an hourly paid staff member? So there are some universities that do things a little bit differently. So at Bradford, all the teaching is done by staff who are both research and teaching active. And this is the case in quite a few universities, but not in all of them. So it's important for you that you check this out. Being engineering, it's important that you have a good grasp of where you would be moving to afterwards. I don't believe just in studying for a job. I think you should study something that interests and excites you as well. But of course, it's important that you know where you're going to fit and where your course will lead to. So industry links are really important. This can come in lots of different ways. So for example, you might look to apply for a sandwich course. And we would recommend all our students do this. So I would say to all of you, please consider doing a sandwich course. It's a year extra as a student, but the benefits are absolutely outstanding. So you tend to do a 12-month placement, and most universities do it like that. And you get paid really well while you're on your placement, but you're also getting training, and it makes you different to the next graduate. And also you find that students who take a placement, when they come back afterwards, their grades tend to go up as well, no matter what grade they were, first of all. Another way of checking whether a university that you're interested in, whether they're employment focused, is ask whether they have industrial advisory boards. So we have them for all of our departments, and we have industrial members who come in and they look at the curriculum and they suggest ideas and they say, these are the big things that are coming up in my world. So these things can help us to, as engineers in universities, help us to develop our courses and make things exciting for students as well. We will, for example, we will say to employers, what kind of things do you wish graduates had more of? And then they will tell us, and then we will look at developing. So for example, they might say, well, at the moment, there's lots of graduates coming through, but they're not really communicating very well. So we will focus on that, for example. So this is the kind of input that the industrial advisory board members can give us. Another thing to think about is, what do students say about different courses? Now, there are different ways of finding this out. If you go to visit universities, then you can speak to current students. There's also UniBuddy, where you can go online and speak to students. One way of doing it, if you can't access the students themselves, is to look at student satisfaction ratings. And at this point, this is where I'm going to say something about league tables. And you'll notice I haven't talked about league tables up until now. My department is very highly rated, as Patricia was saying about her department. So my department is chemical engineering at Bradford, and we're 4th in the UK in the Guardian League table. The biggest part of our measure in that is the student satisfaction. We have really, really high student satisfaction. The reason I say you should be careful and be slightly wary of league tables is that many of the league tables take into account both research and teaching. And for some universities, those things are very, very separate. So you might find a university that comes very, very high in a league table, but actually the student satisfaction might not be so good. So try and unpick the data that's in the league tables. So look at the things that are important to you, and from that you will be able to work out whether or not that university is investing well in its undergraduates, in its students, or if it's focusing more on research. So it's quite an important thing for undergraduates to think about. One other thing that you might want to look at is the extracurricular type activities. So at Bradford, we do something called a Formula Student. Lots of the universities do this. And that's something that's run completely by students. So if you're still not sure and you think, well, there's 2 or 3 universities and I'm not really sure which one will suit me, then you should move into thinking, well, what extracurricular activities might they offer me? And that might help you as well. And then that just brings me on to the last point I wanted to make, which is about research. You may or may not know that most of us who work in universities as academic staff, we are also working as engineers. So we have research projects, and Patricia was talking about hers. And one of the things with the way universities are set up, as I was saying a few moments ago, some universities keep their research and teaching very separate. But most modern outlook universities will actually use their research to help make their teaching exciting and make it better for their students. So at Bradford, we do use research-led teaching. What this means is that we have current research and we bring that into maybe some optional modules. And one of the really exciting things is that for final year projects, students get to go into work in live research areas as well. So if you're not sure which course to choose and you're looking at different universities, one of the things you can do is look at the research profiles of the staff that would be teaching you. And if you look at their research profiles, that will help you get some ideas of where the projects might be, or what labs you might be able to work in, what summer placement schemes there might be, that type of thing. So my research interests, I work in industrial ultrasound. I use ultrasound to monitor usually polymers and other advanced materials during production, and also as an alternative way of melting those polymers, so putting energy into the polymers. I also work in pharmaceutical manufacturer, so the polymer processing and advanced materials work that I do with the ultrasound also has, when I talked about the multidisciplinary nature of engineering, this is a good example. It has applications now in pharmaceutical manufacture and scale up of pharmaceutical processes. So for me and my students, I have students working, you can see the labs here, they come and work in the labs, they work on industrial equipment, they work with PhD students, and they work on things that are actually making a difference to people before they've even graduated. And if you look at some universities, they will allow this. So it's a nice way of differentiating between them. As a picture of my lab, and I put that up just showing a couple of my colleagues. So this week, this was in quite a lot of the press at Bradford, we've got lots of people who are developing PPE to help with the COVID situation. We hear all the time about people using their 3D printers to do this, and it's really important that everybody's making an effort, but actually we can't scale up enough if we're just using 3D printers. But at Bradford, because we've got a lot of knowledge on polymer processing, then the engineers that are working in the same lab as me, you can see them here, they've been able to scale up from 3D printing to actually full-scale injection molding, and it's really, really rapid. Universities have this advantage that we don't have production going on our facilities, so we could change and adapt what we're doing. So you can also look and see in the press what kind of exciting opportunities there are in different universities and give you some other ideas. So that brings me to the end of what I was talking about. This is one of my students, Tariq here. All the photographs that I use at Bradford, we use our real students and all our photographs. And Tariq here is in one of my chemical engineering classes, just about to graduate. So it brings me to the end of the conversation. And of course, as Jon said, I'd be very happy to answer questions. Thank you.
Thank you, Elaine. An absolutely brilliant session as well. Fantastic. Thank you very much. Really, really appreciate that. Elaine, do you mind just clicking stop screen? Yep. If you don't mind, they'll just come back to us just now. Nope. Brilliant. And yeah, I can't say how fantastic those 2 sessions were. When we started it at UniTasterDays, the subject events rather than just general events, that type of event is exactly why we did it. I think students, they would not usually have the opportunity to find out from senior academic staff more about the subject area. So thank you to you, thank you to Patricia. And now we're going to move on to the Q&A, noting that we will finish this session at 4 o'clock. So if you've got other plans later on, and that includes Elaine and Patricia, don't worry, this will finish off at 4 o'clock. But one question I'll start with, and if I can come to Patricia first for it, if that's okay. And it's one, I'm sorry to put you on the spot with this one, because I know you're both senior academics and don't perhaps look at personal statements for students, but one question we always get asked whenever we run events like this is in relation to personal statements. So bearing in mind that you're not admissions tutors and your job doesn't involve looking at personal statements, is there anything, if you were to look at personal statements of students, that you would love to see when looking at places, given that engineering is such a competitive course, and you know, the ratios, as we've discussed, is a consideration for students. So, Patricia, do you mind if I come to you first for that one, please? Oh, Patricia, sorry, you're just muted. Just need to unmute yourself.
Hi, yes, I actually do run the admissions team for engineering, so I do get quite involved in looking at applications and personal statements. We really, first of all, I would say, don't start off with anything that says from an early age, or, you know, that starts off on a bit of a story, really. What we're looking for is to see the passion for engineering and what you've done to follow that passion. So talk about any projects that you've been in, anything that you've volunteered. Have you done any STEM work? Have you been part of the CREST Awards, the CREST Science Awards? Have you participated in things like Primary Engineer or Lego Leagues, or, you know, anything like that? So what we're looking for is to see how you're applying that passion outside of your studies. Obviously, your studies are super important, and without the right studies, you're not going to become an engineer. I look for things like, have you done Gold DV? Are you juggling working, studying, volunteering? Those kind of things. And something that I really rarely do see, but when I speak to people on open days, I do advise them to do this, is to talk about the type of maths that they're studying, because not all A-level maths is the same. And if you're doing modules that are around mechanics, put that in, because if you're not, for example, studying physics, but I can see that you've done modules around solid mechanics. So some of you will have done maths around connected bodies and conservation of momentum, that kind of thing. So that kind of maths content. So if you haven't got physics, it can be that depending on the maths that you've done, it can kind of compensate a little bit. So do talk about the maths that you do, talk about the volunteering that you do, talk about any challenges that you've overcome. Show yourself as a rounded person. Don't worry too much about using long, complicated words. Deliver your passion and your personality to your statement. I think some students, and I've got 2 year 13 twins myself, so I've been seeing them do all their personal statements, and the schools, you know, get them to rewrite and write and craft every word. And certainly that is important, but it's the content. It's, you know, we can see that you are see the person you are. So don't worry too much about overcrafting your statement and impressing people, but do make sure, if you're in year 11 or 12 right now, do look for opportunities to apply your engineering outside of your scholarly activities. That's for me. So I don't know if Elaine wants to add anything to that.
Thank you, Patricia. Yeah, Elaine, do you mind? That's a great answer. I'll pass to Elaine now, please.
Yeah, you've captured pretty much everything there, Patricia. I agree that it's not vital to talk about or to craft this this backstory that you've been doing it forever, because what the admissions tutors want to see is that you've got a passion for creativity and that you're interested in applying yourself, and actually you're interested in learning and learning more. Sometimes when I read personal statements, there can be a lot of similarity, and it's difficult because I know that students have put a lot of work into them, but sometimes they'll talk about the things that interest them, but they don't give any evidence for how they followed that interest. So they might talk about that sustainability is very important to them, but they don't show if they've done any volunteering, or if, like Patricia mentioned, the DFE, if they've tried to develop some skills that would help with whatever area they're thinking of. So it's the rounded aspect of a person that most of the admissions tutors will be looking for. We know, when we look at applications, we know how good your academic ability is, because that's measured from obviously from for most years for the A levels that students do. But it's very difficult to show how open you are to new ideas without showing the rest of you as a personality. It might be that you haven't got time to do extracurricular stuff because you're working as well. So it's about showing how then you juggle your time. So then you've got time management or people management or whatever. So make sure that keep it truthful to you, and try not to worry too much about ticking boxes of what you think an engineer needs to be, because as Patricia said, and this is it's funny because I talk about this as well, the need for diversity in engineering is huge. So if you get 20 personal statements and they're all very similar, then yeah, it doesn't mean they won't be a good engineer, but you don't want a team with 20 similar people in it. So you want to look at that diversity as well. Hopefully
Thank you, Elaine. Yeah, it's brilliant. Yeah. Okay, another one. I won't mention the student's name.
John,
yeah, sorry.
John, could I just say something? Because I realise that not everybody is doing A-levels, and there will be students out there doing BTEC, and I don't want them to feel that they're in any way less of an applicant. One of the things that I would encourage them to do, and if you haven't already made your final module choices, is that you need to look for the advanced, to make sure you're studying the higher level BTEC modules in mathematics. Without, not all universities will take BTEC engineering students. I do, and I believe Bradford does, but a lot of universities don't, or they put them on foundation. I find that some of our best students come from every background. Just because you're A-level students doesn't mean you're going to get a first-class degree. Just because you've got 3 A's in maths, physics, chemistry, you're not going to necessarily get a first class. It's about what you put into it. And so we've got some of our best engineers are BTEC students, some of our best engineers are A-level students, some of our best engineers come from access courses, from IB, from every background. So I don't want anybody to feel that because of the choice that you're making in terms of your studies is going to disadvantage you. But if you are a BTEC student, I would encourage you and make sure that you do take the higher level maths units. I think they're, depending on which course you're doing, it could be Unit 7, Unit 8, Unit 28, but do all the maths modules to do that. And if you're on an access course, make sure that you take the higher level modules, same with IB in things like maths and physics, mechanical science in there as well. So just a shout out to everybody who's not an A-level student. We do welcome you all. And if you need to ask more questions, the Q&A is there.
Thank you, Patricia. I'll whiz through because we've got 6 minutes left, and ideally we'd get through a few more questions. So another question's come in. I won't say the student's name. We'll keep it anonymous. But the question is in relation to MSCs and MEng degrees. I hope I've pronounced that correctly. Is basically one, what the main difference is? Is there one that's better than the other? What are the benefits of each one? Yeah, and if we could just answer it, sorry to say, as quickly as possible, then we'll hopefully get one more question afterwards. Come to Patricia first, please.
Is that okay? I'll be super quick. They are both brilliant, and I think that you should start thinking about your master's degree right now. And the difference, it depends on what you want to do. And I know I'm currently applying for my chartered engineering status. I should have done it years ago. I haven't. Elaine is. The main difference is MEng is an integrated degree. It takes 4 years. And if you have MEng, it immediately tells the world the quality, the high level of accredited quality engineering education you've received. And it meets all the educational requirements for to become an accredited chartered engineer. And we encourage you all to start that journey now. Don't do it 30 years too late, as in my case. Do it, start thinking about becoming a chartered engineer now. And the MEng will put you solidly on that route. The MSc doesn't mean you can't become a chartered engineer. It means, and there are accredited MSCs out there, and we've got them at Coventry University, we've got advanced mechanical engineering, etc. It just means that there's a little bit more work to do to become a chartered engineer. So with an MSc, I've got an MSc. I wish I had an MEng with my application form. It would make my application to become chartered a heck of a lot easier. But with an MEng, you have a single integrated, very high quality accredited degree that plants you firmly on the route to becoming chartered. With an MSc, one of the advantages is you could do something like mechanical engineering first degree, and then you could do an MSc in like renewable energy engineering or something completely different. So that they're both great choices. They both have their advantages and disadvantages. But if you get onto a BEng, MEng route, you can make up your mind during the course of that course which way you want to go, depending on your institute, and talk to your academics at whatever institute you get to. So you don't need to make that decision now. but there are definitely differences and benefits and advantages, and it's for you to weigh them up for yourself with guidance from your tutors, I believe. Sorry, Elaine, did you want to add to that?
There's a couple of things, not much. I think you've been pretty comprehensive there, Patricia. The only other things I would say are most universities, as Patricia was saying, will give you some flexibility. Usually, to be on an MEng course at the end of each year, you'd have to hit a certain threshold of marks, and then you're permitted to stay on the MEng course. Otherwise, you might be asked to go onto a BEng course in some universities, but there is flexibility. Sometimes I will get students asking me about whether they should do an MSc because they want to work, for example, in the Middle East, and they think that maybe an MSc is more internationally recognised qualification than an MEng. But actually what happens is if they do want to go and work in the Middle East, most of the time they're working for large organisations, international organisations or subsidiaries, and therefore they recognise the MEng and the MSc. So yeah, I think at this stage, basically have in mind that you will do a master's, but keep your options, so that talk to the universities and say, well, if I decide that I want to do a bachelor's plus an MSc, will you support that? So that way that keeps your own options open, but you do need to do a master's ultimately if you want to be chartered.
Thank you, Elaine. That's brilliant. In terms of questions, it's 2 minutes to now, so I'll leave it there. If you have asked a question, I can see that there's some questions that have come in that we haven't got around to answering. If you don't mind emailing me, I don't have your contact details with the questions, so otherwise I'll say I'll get answers for you. If you would like an answer to your question still, and we haven't covered it in this session, if you email me, jon@UniTasterDays.com, I'll speak to Elaine and Patricia for you, and fingers crossed I'll be able to get you an answer to that one. But I'm conscious to finish on time because a lot of school groups use the recordings for 1 hour sessions. I don't want to finish the session any later than the hour. So just to finish off from me, a massive thank you to Elaine, a massive thank you to Patricia. That was a brilliant event, and it just makes me think more that subject events are so important for students to go on to make informed decisions, and lots of people will use the recording as well. So thank you very much for giving up your time. Thank you to so many people for tuning in when it's half term. You haven't perhaps got someone that's telling you to all the time, so that's great to see so many people there. And a big thanks from me to the speakers who just delivered wonderful sessions. I'll leave it there. My email address is jon@unitastedays.com if you have got any questions. And if you are interested in upcoming events, unitastedays.com/Tuesdays is where you find out about the general events, which are at 12 o'clock, and then the subject events, which are 3 o'clock. And we've got law next week. I'm sure there's no one watching this that perhaps is looking at both subject areas, but you might know someone that is. So I'll leave it there. Again, thank you to everyone. Do stay safe, and I'll see you all soon. Thank you very much. Thanks.